Alright, so today's going to be pretty short because there's not much to it. It's something that we've learned already. So, get out that worksheet that I handed you on Friday of last week. It was on square root, graphing square root transformations. They look something like this. Okay, we did the simple ones. We looked at ones that looked like this, where the value in front of your x was 1. And we used the same rules that we used for absolute values. This number is going to move us left or right, and this number is going to move us up or down. Okay, so the vertex of this graph is going to be right 1 and up 3. Our slope is whatever's at the front, but remember we figured this one out. Miss Beasley accepted her mistake on Friday as well, that this only will give us the slope of the first point. So if our vertex is at 1, 3, then our next point is going to be up 1 over 1, up 1 over 1, and then we just draw a general curve, and I missed my dot, but we draw a general curve through that point. Alright, so left or right, up or down, slope through first point. Should be review. That's what we've been working on. Okay, on your worksheet you'll see I think a couple that are a little bit more difficult, and by more difficult I mean that the number in front of our x is not 1, so it would be something like 2x minus 1 plus 3. If you remember with our absolute values, when we had a number in front of our absolute, or in front of our x in our absolute value signs, the way that we found our vertex had to change, because when we have a number in front of that x, it becomes a different number because it is multiplied by it. So the way that we found our vertex was we set whatever was in our absolute value signs equal to 0, and we would solve. So our x value was 1/2 and our y value was still 3. With square root signs, it's the exact same process. In order to find our vertex, we set whatever's inside of our square root equal to 0. So our x value is 1/2 and our y value is 3. So our vertex would be found at 1/2, 3. Our slope on the outside is still a 1, so for our first point we're going to go up 1 over 1, and remember we're at 1/2, so right there. So our graph's going to look something like that. We're doing the exact same thing that we did for our absolute value graphs, except now we're doing it with a square root symbol instead of an absolute value symbol. I'll give you one more example. Alright, we look and we see that we have a number in front of our x. So we're going to set everything inside of our square root equal to 0. I subtract my 6. I divide by 6, and I get that my x value is now -1. My y value is whatever's tagged onto the end, so my y value is -1 of my vertex. Then I look to the outside for the slope of my first point. It's 2. Rise over run, up 2 over 1, up 2 over 1. So I'm going to go up 2 and over 1. That doesn't work. That is a very steep slope. Remember that if there is a negative in front of our square root sign, that it's going to go the opposite direction. Okay, we flip it along the x-axis. It'd be down 2 over 1. Alright, so all you're doing with those difficult problems where there's something in front of your x is to find your x-coordinate. You're setting whatever's in the square root equal to 0 and solving. Same thing we did for absolute values. What you'll find out is with transformations, you do the same process for different things. We can apply the same process to multiple kinds of problems. All right, if you have any questions, email me. I won't see you guys until Friday. You'll have a lecture on Thursday. Next week, we will have a test on transformations because we need to move and groove into trigonometry. All right, so again, email me or message me on LMS if you have any questions. That worksheet that I handed you is due on Friday in person. All right, be safe and I'll see you then.